Welcome back to our second day of section 4.4, where today we will continue adding, but we will add in subtracting rational expressions. I want you to start with a warm-up and find the least common multiple of x squared plus 2x and x squared minus x minus 6. When you're done, unpause your video and check your answer. Hopefully you factored the first one as x times x plus 2, the second one is x minus 3 times x plus 2. And then you can see that your least common multiple is x times x plus 2. I include all of that. The x minus 3 I need to put in there. And then x plus 2, though, is already there, so I'm done. So this is your least common multiple. When we continue with subtracting today, the good news is all of the steps are the exact same. It's just when I rewrite it, I'm going to put a subtraction sign between it. And then it's going to cause the simplification of the numerator to be slightly more difficult. Okay, so yesterday we said step 1 is to factor the denominator of each fraction. I'm going to start over here. So x squared minus 6x minus 16 factors as x minus 8 times x plus 2. Okay, so you have to be good at factoring. Again, this time we're finding the difference. So I put a minus sign in the middle instead of a plus. The numerator of my next one is x plus 1. And then this denominator factors as x plus 4 times x plus 2. All right, next I'm going to find the least common denominator, just like we did yesterday, which means I start by taking the whole first denominator, x minus 8 times x plus 2. Then I go to my next denominator. X plus 4 is not in that LCD yet, so I put it in. X plus 2, however, is already there, so I'm good. So this is the least common denominator. My next step then is to make sure each of these fractions has that least common denominator. So I take my first fraction, and I say it currently has a denominator of x minus 8 times x plus 2. And I recognize that it is missing an x plus 4, which means I need to multiply the bottom by x plus 4. And the way I'm allowed to do that is if I also multiply the top by x plus 4. So I do that. Now, since I'm multiplying the top by x plus 4, I need to recognize that x plus 1 is also a binomial, so I must put that in parentheses. Don't forget to subtract. My second fraction starts with an x plus 1 on top, has an x plus 4 times x plus 2, which means it has these two pieces, but that one is missing the x minus 8. So I need to multiply the bottom by an x minus 8 to have the least common denominator, which means I will also need to multiply the top by that amount. So I multiply the top and bottom by x minus 8. Once again, because I am multiplying by a binomial, I have to remember to put that x plus 1 in parentheses. Okay, once we have each fraction with the common denominator, we said we're going to rewrite it as one fraction with that least common denominator as the denominator of the fraction. And then I'm going to move the tops down, and I said in my last couple of examples that I usually simplify as I go, which means I'm going to do my distribution here. I get x squared plus 4x plus 1x is plus 5x. 1 times 4 is plus 4. Now here's the big difference. I need to bring down the minus sign, and the most important thing is that when I simplify the top of my right fraction, I am going to put what I get in parentheses. That is going to be critical. Okay, so I'm going to distribute these. I get x squared minus 8x plus 1x gives me minus 7x minus 8. If you're not remembering how to multiply binomials, you can use the box model off to the side if you want. And again, we're at that point now where we're still simplifying the top. If this was addition, I'd just start adding like terms. But because of the subtraction, before I combine like terms, I need to distribute that negative sign to all three pieces. Some people can do it in their head where they would do that at the same time. I like to rewrite it. So minus x squared, a negative times a negative is plus 7x. Negative times a negative is plus 8. So before I combine like terms, I like to do the distribution so I can see it better. Now I go to combine like terms. I have a positive x squared and a negative x squared. Those cancel out. I have 5x and 7x gives me 12x. And a 4 and an 8 gives me plus 12. Now don't forget, once you've simplified the top, we had a step where we said we need to factor the numerator if possible, and then simplify the fraction. 12x and 12 have a 12 in common, which means it's 12 times x plus 1. I keep rewriting the denominator. The reason I write that out is because I need to make sure that if I factor that 12 out, that x plus 1 can't cancel. But once I've factored all that out, I see that nothing cancels, so this is actually my final answer. We do like to get in the habit of writing our domain restrictions, even though we didn't cancel anything here, so I could actually see all the restrictions. I'm going to put them in. X can't be 8, -2, or -4, because all three of those things would make the denominator 0. Okay, so good review also of what we did yesterday. It's more practice. The difference is you're distributing that negative in this step, so be careful there. Okay, the next layer is we could actually have more than 2 fractions. Okay, so in this case, the fractions are much more simple, but you can see I have 3 fractions at the same time. But my strategy is the same idea, where I first factor the denominators, but when I look at all 3 fractions, there's nothing to factor. So now I have to find the least common denominator. Now this can be a little bit tricky sometimes. If I follow my strategy of taking the first denominator, which is a 3x, then I would go to my next one and there's a 6. So a common mistake would be people would put a 6, but really a 6 is a 3 times a 2, so I already have the 3, so technically I just need the 2. I'll talk about another way to think about that in a second. The x is already there though, and then again, in this case, x squared is an x times an x. I have 1x, so that's taken care of, but this guy isn't there yet. So my least common denominator in this case is actually 6x squared. Another way to think about it when you're looking at it is look at the numbers when they're as simple as this. Look at the 3 and the 6 and you're finding the least common multiple of both. Okay, so it's just 6 because they're both divisible by the same. And then we're back to you take the highest exponent of the x's, so it's x squared. Okay, but I need it to be a 6x squared. Well, my 1 over 3x, I started there. I need a 3x to become a 6x squared. So in order to get that, I would need to multiply the 3 by a 2 and the x by an x. So I actually have to multiply the top and bottom by 2x. Okay, so that's my first fraction, because now we're on the step where we're making each fraction have the right denominator. The second one has 6x on the denominator already, so it's just missing one of the x's. So I need to multiply the bottom by x. So I multiply the top by x. This one started with 1 over x squared. So that's just missing the 6. So I need to multiply the top and bottom by 6. Okay, so as I was saying, we would multiply the top and bottom by 6. Okay, so now when I simplify each of these fractions, so I would actually simplify each of these individually just to be able to see it better. So 1 times 2x is 2x, because then I would see that they have the same common denominator. This is a 1x over 6x squared, and then this one's minus 6 over 6x squared. Okay, you wouldn't have to show that step because we know that those 3 denominators are the same, but I just like them to look the same. Okay, now we're on to the step where we combine them as one denominator, 6x squared, and then I add the 2x plus 1x, and don't forget this is a minus, so it's minus 6. Combine like terms, I get 3x minus 6 over 6x squared. I factor the numerator if I can. I see that there's a 3 in common, so it's the same as 3 times x minus 2 over 6x squared. And now I simplify, and what I see is that I have these two numbers attached to the front being multiplied, and I know they're both divisible by 3, so I'm going to reduce them. 3 divided by 3 is 1, so that's just going to go away. So I'm left with x minus 2 on top, and 6 divided by 3 is 2, so it's over 2x squared. Okay, so that's my simplified form. Don't forget to add those domain restrictions. X just can't be 0 because there was only x's in the denominators. Okay, so that's just looking at an example where you have more than one. Okay, I want you to take a second and try subtracting 2 fractions on your own Remember to factor the denominators first, and don't forget that x squared minus 25 is an example of a difference of perfect squares. So pause the video and try this one, and then come on back to check your answer. Hopefully you remembered then that first denominator factored as x plus 5 times x minus 5, which then made your least common denominator x plus 5 times x minus 5. So the first fraction was fine as is, which was nice. The second fraction, however, was missing the x minus 5. So I multiplied the top and bottom by x minus 5. Once I did that, I combined it as one fraction. The top just comes down to the first one, 3x minus 5. That's as simplified as it can be. Remember, it's minus, so when I distribute the 2x minus 10, I put that in parentheses. Okay, because since it's subtraction, now I have to distribute that negative. So the top actually becomes 3x minus 5 minus 2x plus 10. I have to make sure I do that. Once I do, then I got x plus 5 on the top, which actually then cancels with one of the x plus 5, or with the x plus 5 on the bottom. When nothing is left on top, remember that's a 1, so I have 1 over x minus 5. And this is an example where the domain restrictions are really important because we actually canceled one out. So my domain is that x can't be negative 5 and can't be positive 5. Okay, I wanted to look at one word problem for this. Just to kind of talk about how this is, you could use this. It says Leah drives her car to the mechanic, then she takes the commuter rail train back to her neighborhood. The average speed for the 10-mile trip, so it's 10 miles, is 15 miles per hour faster on the train. Okay, find an expression for Leah's total traveled time. I'm not going to answer the question of if she drove 30 miles per hour, how long did it take, because to be honest, then I wouldn't actually find the expression. So we're just going to find the expression to find her total time travel. Now, in order to do this problem, you do need to know that distance equals rate times time, because those are the three things we're talking about. But again, we want to ultimately find out a time. So if I solve that for time, I would just divide both sides by rate. So time is equal to distance over rate. So if I think about the car, she drives her car there. Both ways is 10 miles. So the distance is 10 miles. And I'm going to say her rate is just r, okay, because they don't tell me anything about her rate on the way there. So the time it takes for her to get there to the place by car is 10 divided by r. Okay? Then the commuter train, on the way home, she still travels a distance of 10 miles because it's the same distance both directions. But in the problem, they told me that the rate is 15 miles per hour faster on the train. So I would take the rate above, so the rate of the car plus 15, because it's 15 miles faster. So the time it takes for her to get home on the train is 10 divided by r plus 15. Again, the question asks for the total time, which means I need to take the time it takes in the car, which is 10 over r, and add it to the time it takes on the train. So this is a really fancy problem to get us to write the expression 10 over r plus 10 over r plus 15, and then they want us to simplify it. So the least common denominator is r times the second one, r plus 15, which means the 10 over r, to make it have that common denominator, I need to multiply the top and bottom by r plus 15. The second equation is 10 over r plus 15. It's missing the r, so I need to multiply the top and bottom by r. When I go to add these together, my denominator is going to be the r times r plus 15. This first one, I get 10r plus 150. Since we're back to addition, I just get to add the 10r on the other side. Last but not least, like terms, 20r plus 150 over r times r plus 15. Now don't forget, so this would be the expression we could use. Okay, so we'll stop there. Having said that, it did say if she drove 30 miles per hour, that would be the rate. So you could plug in 30 for r, but we're not going to do that. I could also, the reason I like the function though, or having this actual equation, is because I could figure out the different times based on her changing her speed. Okay, so the last thing that we need to be able to do this section is to be able to simplify a compound fraction. So first we need to make sure we know what a compound fraction is. So make sure you understand that a compound fraction is a fraction that has one or more fractions in the numerator and or denominator. So you're going to have fractions on top and fractions on the bottom. So the problem will look like this one right here. And the book gives two different strategies. I'm only going to talk about one. The first step I like to use is I like to turn the top and bottom into a single fraction. Okay, so I'm going to turn the top and bottom into a single fraction. What that means is to turn this top into a single fraction, I have to add them together. So I would find my least common denominator on the top, which is x times x plus 1. So I take the 1 over x, it's missing the x plus 1, so I multiply the top and bottom by x plus 1. I add it to 2 over x plus 1, it's missing the x, so I multiply the top and bottom by x. So that is my top, or my numerator of this giant fraction. The 1 over y is already a single fraction, so I leave it. Now I keep simplifying. The top can be written as x times x plus 1 on the bottom. This is just x plus 1. Then I have to add the second numerator, which is plus 2x. It's still all over 1 over y. And last but not least, I'm going to combine like terms on top. So I get 3x plus 1 over x times x plus 1. But now that's all over 1 over y. Now the reason I like this strategy is because once I have the top and bottom set up like that, then I'm allowed to multiply the numerator by the reciprocal of the denominator. Okay, so basically we're going to just multiply the fractions and then simplify. Okay, so we're dividing two fractions, so in order to do that, we change it to multiplication. So I take the numerator, 3x plus 1, over x times x plus 1, and I multiply it by the reciprocal of 1 over y, which is y over 1. Now I multiply straight across, top times top, bottom times bottom. So on top, I'm left with 3x plus 1 times y over x times x plus 1. And they actually allow me just to leave my answer like this. But don't forget, we still have to include domain restrictions. And the key is that the domain restrictions must include restrictions from every fraction in the problem. So way back to the very beginning. Okay, so even in this very beginning, I see x can't be 0 because there's an x there. X can't be negative 1 because there's an x there. And we would have had that from here, so that wouldn't have been a big deal. But we also had this y in the denominator. So I guess it's not even just restrictions, it's not domain, but it's just restrictions, so y can't be 0 either. So those are the three restrictions we have to put in place for this to work. Okay, let's do one more together here. 2 minus 1 over x divided by x plus 2 over x. So again, first I'm going to think of the LCD on top, which is just x, because this is like a 2 over 1. Okay, so in order to make the 2 over 1 have a common denominator of x, I need to multiply the top and bottom by x. Minus 1 over x is fine. That already has the least common denominator. Sometimes I like to just simplify one fraction at a time. This allows me to change the top over x, and then it's 2x. And remember, as soon as it's subtraction, just make sure you put minus that. Okay, so I make my top a single fraction, and then I take the bottom. My LCD of the bottom is also just x. So I had x over 1. I need to make it have a denominator of x, so I multiply the top and bottom by x. Plus 2 over x already has that LCD, so we're good. Rewrite that fraction over x, so the bottom is good. X times x is x squared plus 2. Okay? So now that I have a single fraction divided by a single fraction, I take the numerator, 2x minus 1 over x, and I multiply it by the reciprocal of the denominator, so I flip it, so it's x over x squared plus 2. If I multiply straight across, I get 2x minus 1 times x over x times x squared plus 2. Don't forget to simplify. This x is going to cancel this 1 out, so I get 2x minus 1 over x squared plus 2. Now just as a quick side note, I could have gotten away without rewriting it this time. I understand that when I multiply straight across, everything here is going to end up on top, so you could have just canceled the x's out right here. Okay, that's typically what I would do. And then the restrictions are that x can't be, remember we crossed out, there were x's in the denominator, so x can't be 0. This one would be imaginary, so that's all I need. All right, last but not least, I want you to try one of these on your own. So pause the video, work through this one, and then check your answer to see if you got it. So the top was fine, we didn't have to do anything with that. On the bottom, we can see that our LCD should be 3 times x minus 1. So I made each fraction have that. I had to multiply the top one by x minus 1 and the second one by 3. When I simplified the top, you can see I multiplied this out. I got x squared minus 1, but then plus 12. So x squared minus 1 is x squared plus 11. So I take the numerator times the reciprocal, so 3 times x minus 1 is on the bottom, over x plus 11. And you can see in this case, I did cancel before I multiplied straight across, because I can cancel anything on top with anything on the bottom when I'm multiplying. So I'm just left with 3 over x squared plus 11. Don't forget, I canceled out that x minus 1, so x can't be 1. All right, so that's the end of section 4.4. Okay, so again, we worked on adding and subtracting rational equations. And then we also finished up with these things called compound fractions. Go ahead and work on your 4.4 day 2 Pearson practice, and we'll see you in section 5.